Welcome back, Minecrafters! Gigahertz Productions here, and today I have a video formed from the very essence of redstone. And today I'm going to be showing you the basic components of redstone circuits and other contraptions that use redstone. So basically, to help expand your knowledge and get a better understanding for redstone. And make sure to stick around until the end of the video because I have a little machine that I built to show you at the end. Okay, let's start off with the redstone components. Just a quick note, if by the end of this video you are still confused, go and check out the Minecraft wiki on redstone. There will be a link in the description, and the wiki has very in-depth explanations, and it gives a lot of information, so go and check it out if you're confused. And now, a second note, if you guys are more advanced in redstone, head to the timestamps 10 minutes and 30 seconds and 17 minutes for the more complex circuits and stuff. Now, I would think that most of you that play Minecraft would know what redstone is. It's this ore right here. So it's a red looking ore, and you can mine it up to get redstone dust. So redstone, or redstone dust, looks like this, and it's essentially the wires and everything that is connected together in all redstone contraptions. It's like the glue that holds everything together. Now, moving on, we have a redstone torch. And redstone torches and redstone blocks and any other power blocks can power redstone dust like this. See, that's powered redstone dust, and it can power it for 15 blocks. And other things that can also power redstone are levers and buttons and pressure plates and other things like that. And a cool thing with the redstone torch is that when it has an input, it will give out an opposite output. So when the redstone is on, then the redstone torch will turn off. So that can be quite useful in redstone contraptions. Now we have the redstone block, and this is just like a power block and can power redstone for 15 blocks. Like you see here, it's powering these redstone lamps, which is the next thing. So redstone lamps can either be powered or unpowered, and they can be used for like signals and like display boards or whatever you're building. Now, moving right along, we have these two guys right here, which are droppers and dispensers. So droppers have like the triangle mouth, and dispensers have the circle mouth. And essentially why they are different is the dispenser will dispense out the like actual item, but not in like item form. So if we put a cow spawn egg in there, we will get an actual cow. When you flick the lever on a dropper, then the cow spawn egg will pop out rather than the actual cow. So that's what makes the dropper and the dispenser different. Now, moving on, we have pistons. And pistons can either be extended or retracted, and there's two types of pistons. There's the regular piston here, and the sticky piston. And what makes them different is that the sticky piston can pull blocks back. So if we put a block of iron here and then turn off its power, you'll see it pulls that block back, whereas a regular piston cannot pull that block back. And pistons, they can push 12 blocks. So if you have 12 blocks, they can push them, but any more than that and your piston won't do anything. Next, we have this little serious guy called an observer, and essentially he detects block updates. So whenever there's a block in front of him, then he will see that and basically send out a redstone signal. So with this guy, you can basically make every single block in Minecraft can be used for redstone. And see here, if we place down an iron block, you'll see a quick flash come out of him, and when you destroy it, he senses it again. Now, moving on to hoppers, they essentially suck items, so any items that are floating above the hopper will be sucked down, and when you see a hopper in this configuration, so their little bottom nozzle is pointing out in a certain direction, the items will flow out to whatever it's pointing into, or they'll just stop where if there is nothing that this thing is pointing into, like here. An important thing to note is that if the hopper pointing to the side is not pointing into anything like a chest, then the items will flow downwards if there's another hopper below that hopper. So just to show you, I put down another hopper here, so the items will flow to wherever this thing is pointing, and then they'll flow down if this is all filled up. So I put chests up in the top, and now they should be in here, which they are. So those are the hoppers. And now this is a daylight sensor. So basically it senses if it's either day or night, and it can also sense the other times of the day, so like when it's like sunrise or sunset, and where the sun is in different points of the sky. And right now it's sensing, it's inverted, so this is an inverted daylight sensor where it has a more bluish color, and it's giving no signal because it's sensing if it's nighttime, which it's not. And then if we put it to its regular form where it's sensing if it's day, you'll see it's giving a signal because obviously it's day out. Next we have a couple of probably the most useful components in a redstone circuit. We have a repeater which can slow down the tick, and a tick is 1/10 of a second. So this right now is set to 4 ticks. So that's 4/10 of a second. This is 1/10 of a second, 2/10, 3/10, and 4/10. So this can slow down your redstone signal and help with timings of pistons and other things. Just depends what you're doing. A thing I forgot to mention is that if a repeater is being powered, it will power another 15 blocks of redstone. So it's like resetting the redstone back to full power. These things can also hard power blocks, and we'll get into that a little bit later. Next we have the comparator, which can also hard power blocks. And comparators can sense items in like a hopper or dispenser or anything with like inventory space. That is not yourself, the player. And it can detect that and then give out a redstone signal. It can also repeat redstone signals when it's in this form where the light at the end is lit up. Next we have the lever, which is where you flick it on, it will give a constant redstone signal for 15 blocks. So that's pretty self-explanatory. And then next we have 2 different types of buttons. There are the wooden buttons, which give a 15 tick pulse or 1.5 seconds, and this one, the stone button, will give a 10 tick pulse, so that will be 1 second. So if we push them, you can see that the wooden button stays much longer in the downward position. Then we have tripwire hooks, and these can be used to send redstone signals with string. So when like a player or entity steps on them, then you can have a redstone signal from the tripwire hook. Next we have these pressure plates, the unweighted ones and the weighted pressure plates. So the unweighted ones can be pushed down by yourself and other mobs or entities, as well as it can be pushed down by items. So if we throw any old item on it, you'll see it's being pushed down. But with the weighted ones, if we throw an item on it, they cannot be pushed down by those items. And now moving into rails, these aren't really, these rails in particular aren't really redstone related. They're just used in lots of farms to move minecarts around to collect items. But these powered rails can be powered on and off by redstone. And then these detector rails can give out a redstone signal, as well as these activator rails can also be powered by redstone. And now here are the couple different types of minecart. So there's a minecart with a chest, which has inventory space and stuff. And there's just a regular minecart, so if it has a player or entity, or mob I should say, in it, then the detector rail can detect that. And then finally, probably one of the most useful ones is the hopper minecart, and this is used in a lot of farms because it can suck blocks down, or rather it can suck items down through a 1 block space. So that can be very useful in farms. And there's one minecart that I forgot. There's also the minecart with TNT. So this can just basically blow up things, and if you drop it, it will blow up instantly. So when you drop it and it falls and hits the ground, then it will blow up instantly rather than waiting a couple seconds. Now moving into a thing that you might not think has a redstone signal but actually does, we have a lectern with a book on it. So when I will use this, you will hear the note block play a note, and that's the redstone signal coming out. So whenever you flip a page on a book on a lectern, it will give out a redstone signal. So you should be able to hear the note block playing a note. See, it works. And now note blocks can obviously be affected by redstone, as we saw earlier with the lectern. So whenever it has a redstone signal, it will play a note. Same goes for with a bell. Whenever it has a redstone signal, it will ding. And I also decided to include doors and fence gates and also trapdoors because they can be affected by redstone. Like whenever they get a signal, they were either open or closed, but they're not really a redstone component. Now a thing that's not really related to redstone but is used in many redstone contraptions is honey and slime blocks, because they stick together and can move blocks because they stick to them. But honey and slime blocks, they do not stick to each other, so they're very useful for massive piston doors and also flying machines, which we'll get into later. Now moving into a couple of simple circuits, we have this circuit here, which is essentially a repeating redstone signal. So you use your comparator with delay at the end to repeat the signal, so when it has an input, you'll just get a very quick repeating signal. And here we have a toggleable redstone clock. So whenever there's an item in this dispenser, then it will toggle this redstone clock, and you can slow the clock down by increasing the ticks of the repeater. And a way you can modify this is if you do not want the dispenser to spit out the items, then you can just remove that redstone right there, and then you just got this clock, which you can take out the signal. Now moving into a couple other variations, you have this variation that uses two hoppers pointing into each other, so the items will travel back and forth and give a redstone signal to this comparator. And when you... oh yeah, another thing I forgot to mention earlier is that when a hopper gets a redstone signal, it'll lock that hopper, which means that no items can flow through that hopper. So right now this hopper is locked, so it's not running, but when you unlock it or turn the lever off, then you'll see that there is an item flowing back and forth in between here. And here is another design that uses observers, so they observe each other, and then they give out a redstone signal, and they keep on doing that forever. And so basically the piston pushes the observer out of the way, but when it comes back and sees the other observer, then they observe each other and give out the redstone signal. And there are many more different types of clocks. Some that can give a very ridiculously long pulse, or they take a really long time to give a signal. Now moving into what I said before with hard powering and soft powering. Hard powering is when you power a block with a repeater or a comparator pointing straight into that block. So not only does it power the block, but the redstone signal carries through, and you can continue on the redstone signal on the other side. But as you see here, if you just power a block with just redstone, this is soft powering, and it will only power the block but not through. So as you can see, the block is still powered, so if you put a redstone torch, it should turn off, which it does, because this block is powered, but it cannot go through. And as you can see here, the comparator or repeater has to be right up against the block. It cannot be like 1 block away or 3 or however many. It has to be right up against in order for it to hard power. Now moving into ways for you to carry your redstone signal upwards. At first, this may not look like it works, but it does with the way that redstone interacts with these transparent blocks. So redstone can travel up, it thinks it can travel like up through here and then also up through there, but it cannot travel downwards, it only travels upwards. That's just how the mechanics work. As you can see, it works just fine. Another way you can get a redstone signal upwards is using a torch tower. So you basically just put a torch and then a block and then a torch and then a block and then a torch and then a block. One thing you have to be careful of is that you line up the right redstone powering because the torches, they switch every time, so either they're off, so they go off and then on and then off and then on. And then one last way is using observers that observe the redstone down below. So when you flick it, you get a very quick pulse because they observe that redstone and then they send a signal into this block, which powers this block, and then that redstone gets powered and that observer sees that and then powers the block above, and so on as far as you need to go. So those are ways that you can get redstone to go upwards. So here we have a double piston extender in Bedrock edition, and in Java edition it's much smaller. You only need like 2 repeaters and then redstone just running through them. But in Bedrock, the redstone is slower, so you can solve that by just adding more repeaters. So you just need to go with the 0 tick, 8 tick, 4 tick rule, and this will give us our full extension and full retraction. Just like that. And they are quite simple to build. Next, we have a couple of very simple redstone contraptions that I built very quickly just to show you what you can do. So with pistons, you can make a little door to your goodies or whatever. Very simple to build. And this one is a little fun because if the hallway was longer and you couldn't reach these items, it's kind of like a locking mechanism. So when you run up and hit the pressure plate, the doors close. So you can prevent your friends from getting your stuff. Moving on, we have a slightly more complicated contraption that's flush with the wall. And this one, if we flick the lever... Uh-oh, something broke. So now this thing should work. There we go, and see, it opens up, and then we can access our diamonds and other goodies and whatever you put in that chest. Next, we have this little disappearing stairway, so you can walk down into your basement or whatever you have down this hallway that you can extend out. But then if you want to access whatever is under your stairs, you flick this lever, and then the stairs open up. But a little thing that I added is that you can also close the stairs from the inside, so you can like hide in here from your friends or whatever. But also you have to be careful because there's also a little trap of lava. So then if your friends or you aren't careful, then you'll fall to your death. And then you can open it back up again and close it. Another quite simple contraption. Now, moving into a slightly more complicated one, these are flying machines. So basically, the pistons will push each other in one direction, so then they'll keep on going. So basically, one will push and then one will pull that part back. So this one will push these 2 components that way, and then this one will pull them back, pull the parts up here back, so then it will keep on going. And all we have to do is add an observer. Something is not quite right with this. I might need to do a little bit of Googling. How to build a flying machine in Bedrock. So the only thing that was actually wrong with our design is that we needed just a regular piston here instead of another sticky piston. So it should be a sticky piston and a regular piston, and hopefully now this should work. And an observer update. There we go. And we send it off forever and ever until it hits render distance. Then it will just stop and break. And this one here is basically the same design, just that it's flipped 90 degrees, so it's facing upwards. And actually it looks like it's pushing downwards into the ground, but you get the idea. This thing will keep on going downwards. That one went off in that direction. And if you flip this the right way, which I didn't, then it should travel upwards. And flying machines can be quite useful for farms, because if you put out a flying machine, it can go like across crops or whatever and knock out all the stuff and push it to like hoppers at the end, and they're in general quite useful and very fun to use in farms. Now moving into a little bit more advanced redstone circuitry and stuff, we have the logic gates. So there are three types, or four I guess, but three main types of logic gates that I have here, and that is the AND gate. So if this and this is off, then you get an output. So these can be used in different redstone contraptions to do different things. Always depends on what you're doing. So this is an example of an AND gate. This is an example of an OR gate because this one or this one can be on to get an output. But if both of them are off, then you do not get an output. And if both of them are on, then you also get an output. So this is an OR gate. And this is an RS NOR latch, and it is kind of like a T-flipflop, which we'll get to later, but instead it's in latch form. So if we hit this button here, then the redstone signal switches, but if we hit it again, then nothing happens. And then now we have to switch this one in order to switch the signal. And essentially it just uses some redstone and these redstone torches to do what it does. And these things can be very useful in security systems and other things along those lines. Lastly, we have the NOT gate. So when it doesn't have a input, then it will have an output. So if we do give it an input, then we'll have no output. So this is the example of a NOT gate. Now moving into monostable circuits. You might have heard other redstoners say monostable circuits, and you might have been like, what the heck does that mean? Well, essentially it means that they're turning a pulse of, in this case, 10 ticks into a very quick 1 pulse tick. The only problem with this design using observers is that it will give 2 pulses. So, as you can see, when you hit this, you get a very quick flash and then another quick flash. Same thing with this one, just that it uses a redstone torch instead of redstone. So it's just a different design. But now moving on to this one, which is the most useful one because it only gives out 1 tick. And these ones are useful if you're trying to get 2 pulses out, but they're not as common. And this is probably the most common version of a monostable circuit in Bedrock. I do believe this will not work in Java. So it's just a block with redstone, then a piston with a block on it, and then a repeater, and then another redstone dust, and then whatever is your output. So if we turn this on, we get a quick flash. And this here would be an example of a Tflipflop in Java edition, but it does not work in Bedrock, and instead it's just an overcomplicated version of a monostable circuit. So at the end we only get a single little pulse there. So it's just like a monostable circuit, except for just with extra stuff that you don't need. But a T-flipflop that does work in Bedrock edition is this here that uses dispensers and hoppers. And first, I should probably explain what a T-flipflop is. So basically, when you get an input signal, it will either turn the output signal on or off, and it will stay on or off forever until you get another input. So if we get one input, then this signal will stay on forever until we get another input, which will turn it off. And so basically, there's just an item in these droppers. It will travel around in a circle, so then this comparator can sense when the item is going through. So if we take a look, the item should be in this down one here when it is off, which it is. And then over here we just have a different version of the T-flipflop design there. It's just skinnier and in this direction. And basically it just has a different footprint. It works exactly the same. It's just a slightly different design. So as you can see, when you flick the lever, you get an output. And when you flick it again, it turns off. And the items travel in this kind of direction. Now lastly, before I show you my fancy redstone contraption that I came up with, we have these pulse extenders. So they basically do what they say, they extend the pulse, and to do it, all you need is a couple of comparators and some redstone thus linking them up. So what they do is they will extend the pulse. And the more comparators that you add, the longer of a pulse you will get. So you can see this pulse is lasting much longer. Now the moment that most of you have been waiting for. Let's turn on this machine and see what it does. Ta-da! Now, you will notice that I did cheat a little bit by putting that redstone there and then breaking it again, but it was just getting too much of a headache and a hassle to link this up properly, and I was just getting tired of it. So some of you might have recognized that to be Megalovania from Undertale. So, yeah, I hope you enjoyed. So, I hope you improved your redstone skills and now have a better knowledge of redstone. And hopefully you can build better contraptions and, in general, just be better at redstone. Now with that amazing song now in our ears, Gigahertz Productions out!